Hey everyone, and welcome to this video about currently prevailing blockchain subnets. In the last video, we spoke about what a blockchain subnet is. Watching it will give you a pretty good understanding of how subnets work. So if you want a refresher on that, or are completely new to the topic, I highly recommend checking it out. This video will focus on the comparison between three of the biggest blockchains in the subnet space: Cosmos, Polkadot, and Avalanche. This video will compare them over multiple parameters like scalability, decentralization, latency, among others. Cosmos is a heterogeneous network of many independent parallel blockchains, each powered by classical BFT consensus algorithms like Tendermint. Developers can easily build custom application-specific blockchains called zones through the Cosmos SDK framework. These zones connect to hubs, which are specifically designed to connect zones together. The vision of Cosmos is to have thousands of zones and hubs that are interoperable through the Inter-Blockchain Communication Protocol, or IBC. Polkadot is a heterogeneous blockchain protocol that connects multiple specialized blockchains into one unified network. It achieves scalability through a sharding infrastructure with multiple blockchains running in parallel called parachains that connect to a central chain called the relay chain. Developers can easily build custom application-specific parachains through the Substrate development framework. It uses a hybrid consensus mechanism, Babe and Grandpa, which is a platform of platforms, ultimately consisting of thousands of subnets to form a heterogeneous interoperable network of many blockchains. It uses Avalanche consensus as the protocol of choice to provide a secure, globally distributed, and interoperable framework. It was built with serving financial markets in mind. Now let's talk about the scalability of each blockchain. Each zone and hub in Cosmos is capable of up to 1,000 transactions per second, with bandwidth being the bottleneck in consensus. Cosmos aims to have thousands of zones and hubs all connected through IBC. There is no limit to the number of zones or hubs that can be created. Parachains in Polkadot are also capable of up to around 1,500 transactions per second. The number of parachains is limited by the number of validators on the relay chain. They hope to be able to achieve 100 parachains. A portion of the parachain slots on the relay chain will be designated as part of the parathread pool, and the performance of the parachain is split between many parathreads. This makes the relay chain the bottleneck. Avalanche is capable of around 4,500 transactions per second per subnet, and if higher performance is required, then more specialized subnets can be created with higher minimum requirements to be able to achieve 10,000 transactions per second plus in a subnet. Avalanche aims to have thousands of subnets, each with multiple virtual machines and blockchains all interoperable within each other. There is no limit to the number of subnets that can be created. Now let's talk about the level of decentralization each blockchain offers. Tendermint consensus, the consensus mechanism Polkadot uses, is limited to around 200 validators before performance starts to degrade. Whilst there is the Cosmos hub, it is one of many hubs in the network, and there is no central hub or limit on the number of zones or hubs that can be created. Polkadot has 1,000 validators in the relay chain, and these are split up into a small number that validate each parachain, with a minimum of 14. The relay chain is a central point of failure as all parachains connect to it. The number of parachains is limited depending on the number of validators. They hope to achieve 100 parachains. Due to the limited number of parachain slots available, significant sums of DOT will need to be purchased to win an auction to lease the slot for up to 24 months at a time. Avalanche consensus can scale to tens of thousands of validators, even potentially millions of validators, all participating in consensus through the repeated subsampling. The more validators, the faster the network becomes as the load is split between them. Because of the way the architecture is made, there is no limit to the number of subnets or virtual machines that can be created. Now let's compare the latency between these three subnet providers. Consensus used in Cosmos reaches finality within 6 seconds. Communication between two zones could pass through many hubs along the way, thus also can contribute to latency times depending on the path. It doesn't need to wait for an extended period of time with the risk of rollbacks. Polkadot provides a hybrid consensus model consisting of block producing protocol called Babe and then a finality gadget called Grandpa that works on agreeing on a chain out of many possible forks by following some simpler fork choice rules. Rather than voting on every block, it instead reaches agreement on chains. As soon as more than 2/3 of the validators attest to a chain containing a certain block, all blocks leading up to that one are finalized at once. With this mechanism in place, finality is reached within 60 seconds between parachains. Avalanche consensus achieves finality within 3 seconds, with most of them happening with sub 1 second immutable and completely reversible times. Any subnet can connect directly to another without having to go through multiple hops, and any VM can talk to another VM within the same subnet, as well as external subnets. It doesn't need to wait for an extended period of time with the risk of rollbacks. Now we can take a look at shared security in these blockchain subnets. Every zone and hub in Cosmos has their own validator set and different trust assumptions. Cosmos are researching a shared security model where a hub can validate the state of connected zones for a fee, but it's not released yet. Once available, this will make shared security optional rather than mandatory. Shared security is mandatory with Polkadot, which uses a shared state infrastructure between the relay chain and all of the connected parachains. If the relay chain must revert for any reason, then all of the parachains would also revert. However, parachains can't just rely on the relay chain for their security. They will also need to implement censorship resistance measures and utilize proof of work or proof of stake for each parachain. A subnet in Avalanche consists of a dynamic set of validators working together to achieve consensus on the state of a set of many blockchains, where complex rule sets can be configured to meet regulatory compliance. So unlike in Cosmos, where each zone or hub has their own validators, a subnet can validate a single or many virtual machines or blockchains with a single validator set. Shared security is optional. Enterprise adoption is an important thing to consider when comparing different blockchains that provide subnets. Cosmos enables permissioned and permissionless zones, which can connect to each other with the ability to have full control over who validates the blockchain. For permissionless zones, each zone or hub can have their own token and they are in control of who validates. In Polkadot, the state transition is performed by a small randomly selected assigned group of validators from the relay chain. This may pose a problem for enterprises that need complete control over who performs validation for regulatory reasons. In addition, due to the limited number of parachain slots available, enterprises would have to acquire and lock up large amounts of DOT, a highly volatile asset. Avalanche enables permissioned and permissionless subnets, and complex rule sets can be configured to meet regulatory compliance. For example, a subnet can be created where it is mandatory that all the validators are from a certain legal jurisdiction or they hold a special license regulated by the SEC. Subnets are also able to scale to tens of thousands of validators. The interoperability of a blockchain provides across its subnets can be a huge factor in which you choose to use. Cosmos is interoperable across a path of connected zones and hubs. It has different levels of trust. In Polkadot, all parachains share the same trust assumptions on the relay chain validator set. Polkadot enables the ability to connect to external blockchains through bridge parachains. Unfortunately, Polkadot has long finality times with external blockchains and a limited number of parachain slots. Avalanche is interoperable by design, both within a subnet as well as between any subnet. There can exist different trust levels at the subnet level as well. In Avalanche, the primary network can be leveraged. Avalanche also enables the ability to connect to external blockchains through bridges. Thank you so much for watching this video. I hope this video gave you a lot more information about the differences between Cosmos, Polkadot, and Avalanche, the three major players in the blockchain subnet space at the moment. Thank you for watching, and I'll catch you guys in the next video.